Okay, students, welcome. Okay, good day, students. I'm having a very fresh lesson for you guys today. Okay, solution to NECO 2021. The one that was written on Thursday, 29th of July 2021. Okay, and well, I have 1 to 60 questions here. I want to deal with the objective aspect first, then we'll now go into the theory aspects. Okay, as you can see that this is the NECO we're talking about. Okay, so National Council. So this particular year, NECO was written before WAEC. Are you there? So we in the recent years, WAEC was written before NECO, but due to COVID-19 here in Nigeria, so I mean in the whole world, are you there? So we had to they had to write NECO before WAEC. So I think this is August. So by October or so, WAEC will be written. So your understanding of by the time I go through these questions and I explain and analyze everything, are you there? You will be able to use that understanding for NECO, because the topics are almost the same thing. About 45 topics, in the physics. Are you there? So they are almost the same thing. So what matters most is the understanding of the concept of each of the topic. So whatever you see here in NECO, you also see it in WAEC. So as in terms of topics. Okay, let us start from number 1. Let's start from number 1. So I'm going to analyze it very well in such a way that we're able to understand the concepts. Okay, physics is interesting. Let me drink water first. Life is simple. Just take life simple. Life is simple. Life is easy. Someone said that physics is interesting but challenging. So what's your take on that? Physics interesting but challenging. To me, it is interesting. The challenging aspect of it is that you just have to put your SI unit, convert your unit, this and that, and all that. Once you have mastered that, it becomes simple for you. Okay, please don't forget to click on the subscribe button. Just click on it, and the like button, click on it, please. Okay, so I will see more videos that I've uploaded. Okay, so I also, okay, let's start from number 1. Number 1 says, which of the following set of SI units is fundamental only? Which of the following set of SI units is fundamental only? We have the fundamental quantities, are you there? And with their respective units. Fundamental quantities and their respective units. So we have the length, whose SI unit is meter. We have the mass, whose SI unit is kilograms. So you can bring out a paper and pen, and jot something down. So I repeat, we have fundamental quantities. They are 1, length, whose SI unit is meter. Mass, whose SI unit is kilogram. Time, whose SI unit is seconds. Electric current, whose SI unit is amperes. Then we have temperature, whose SI unit is degrees Celsius or Kelvin. Then we have amount of a substance, whose SI unit is mole. Then we have the last one, we have the luminous intensity, whose SI unit is candela. represented by abbreviated as CD. Okay, so they now said which of the following set of SI units is fundamental only? Option A, amperes, mole, meter square. Option A is wrong because meter square is the SI unit of area, and area is a derived unit. So A is wrong. B, we have the candela, CD, mole, MOL, Kelvin, K. So this option is correct. This option is because CD is the unit of is the abbreviation for candela, which is SI unit of luminous intensity. Mole is the SI unit of amount of a substance. Then K is Kelvin. So option 1. So with this my answers, you are able to like know the kind of scores that you will get before the result comes out. Okay, so option number 1 for NECO, number 1, option B is correct. Option B is what? Correct. Look at option C. Let me just analyze option C. Option C is Newton. Newton is a derived unit. Candela, yes. Meter per second. Meter per second is the unit of velocity or speed. Option D, Newton. Meter cube, meter per second square. Meter cube is the SI unit of volume. Meter per second square is the SI unit of speed or velocity. The option E, seconds, joules and Kelvin. Joules is the SI unit of energy, and energy is a derived unit. So the correct option is B for number 1. Correct option is B. Now, when it comes to calculation, I will solve it on the board. Okay. Number 2, which of the following bodies exhibit translational and rotational motions simultaneously? Which of the following bodies exhibit translational and rotational motion simultaneously? Simultaneously means at the same time. So a body that performs both translational and rotational motions simultaneously. Translational motion has to do with the movement of a body from one place to another. There must be a movement from one place to another. Rotational motion is when a body is moving in a circular path about a particular axis. So let's look at the option. Option A, a bee hovering over a flower. Bee hovering over a flower. That is a rotational motion alone. But we are looking for translational and rotational motion. Option B, book sliding down an inclined plane. When a book is sliding down an inclined plane, it is performing translational motion. Okay, only. Now, option C, cylinder rolling down an inclined plane. Cylinder rolling down an inclined plane. The cylinder is rolling. The cylinder is rolling. That is rotational motion, and it is moving down the inclined plane, moving from one place to another, maybe from the top of the plane to the bottom of the plane. It has changed from one point to another. That is translational motion. So cylinder rolling down an inclined plane is a rotational motion, and at the same time translational motion. Let's look at option C is the correct answer. Let's analyze option D. Option D, stone thrown vertically upward. For option D, stone thrown vertically upward, that one is a translational motion. Wheel, option E, wheel moving on a circular track. When a wheel is moving on a circular path, that is a rotational or circular motion. So the correct option for number 2 is a cylinder rolling down an inclined plane. So let's go for number 3. Number 3 question for this NECO 2021. With this now, begin to mark yourself. Number 3, which of the following statement is not correct about velocity? Which of the following statement is not correct about velocity? It is option A. It is a vector quantity. Yes, velocity is a vector quantity. It has magnitude but no direction. So it's a vector quantity. Option B. It is a time rate of change of displacement. Yes, velocity is a time rate of change of displacement. Velocity is displacement over time, while speed is distance over time. So option B is correct. We are looking for the one that is not correct. Okay, right. Option C. It is measured in meters per second. Yes, the SI unit of velocity is meter per second. Okay, that one is correct. Option D, Speed measure, it is the speed measured in a given direction. It is the speed measured in a given direction. Yes, velocity is a speed measured in a given direction. The difference between speed and velocity is that speed is a scalar quantity while velocity is a vector quantity. So it's just all about direction. Either that speed has magnitude but no direction, but velocity has magnitude and direction. So they have the same unit, meter per second. So we can say velocity is the speed measured in a given direction. Okay. Option E. Option E is it is uniform round a circular path. No, velocity is not uniform round a circular path. For a circular path, it is the speed that is uniform because it has something to do with direction. Velocity is not uniform. It is changing. Are you there? Velocity is changing around a circular path. Look at this circle here. Okay, this is a circular path, for example. Okay, let's assume a body is here. Are you there? If a body is here, its direction is, let's say, in this particular path. When the body is here, its direction is in this particular path. Are you there? When it's here, let's assume it is here now, its direction could be in this path. When it's here, its direction could be in this path. Okay, so since direction is changing, then velocity must also change. Velocity must also change, but speed will not change. Okay, so the correct option is option E. So uniform round a circular path is totally wrong. So which of the following statement is not correct about velocity? It is uniform round a circular path. So option E is wrong. So let's go to number 4. Number 4, they gave us, they say calculate the total distance covered. Let me sketch the diagram on the board for number 4. For number 4, this diagram. So this is the velocity in meters per seconds, and this is time in seconds. Are you there? We have this, we're given this, we have this, and we have this. Okay, here is 8. Okay, here is 5, and here is the origin. Here is 10. Okay, so this is the diagram. They say calculate the total distance covered during the motion represented in the velocity time graph shown below. So you calculate total distance travel is the area under the graph, is the area of the shape you are seeing. The shape is a trapezium. Okay, the shape is a trapezium. So area of a trapezium equals to half bracket a plus b times height. Okay, the a and b are the two parallel sides of the trapezium. That is this side, this line, and this line. Okay, so this line, this line, and this line, they are the a and b. Are you there? They are the two parallel sides of the trapezium. Okay, and this is the height. This is the height of the trapezium. So let's calculate it. That's the 2. So equals to half bracket the a. The diameter a is this. This is diameter, which is, when you look at it, it's not 10. No, look at it down from here to here. Look at it. That is 5 minus 0. Okay, so diameter a is 5. Then plus the b. The diameter b is the longer side from here to here. That is 0 and 8. So 8 minus 0 is 8. So the height is, this is the height. Look at the height here. Okay, so to get the value for the height, you go this way. That's 10. For value for the height is not 5. Look at it. Look at my hand, 2 fingers. This is height of trapezium. That's 10. So equals to half times 13 times 10. Okay, and that gives us 65 meters squared. So that is the area, 65 meters squared. So Now the total distance covered is the area under the graph, is the area. So the total distance covered is now 65 meters. So you have to conclude, if it were to be in theory, you write therefore the total distance traveled equals to what? 65 meters, not 65 meter squared. So option A is 25 meters, option B is 30 meters, option C is 50 meters, option D is 65 meters, while option E is 80 meters. So the correct option is option D, 65 meters. Number 4, option D is 65 meters. For question number 4, option D, 65 meters, is the correct answer. So let's go to number 5. Number 5, two vectors 10 newtons, west and 15 newtons east originated from the same point. Two vectors 10 newton west and 15 newton east originated from the same point. Calculate their resultants. This is simple. Vectors have magnitude and direction. 10 newton west, 10 newton is the magnitude, west is the direction. 15 newton east, 15 newton is the magnitude, east is the direction. Okay, so now go back to their 4 cardinal points. We have this: north, south, east, west. Okay, now say two vectors 10 newtons west, 10 newton west. The first one is 10 newtons west. Where is the western part? This side. So this is the west. Put the arrow, and that's 10 newtons. 10 newtons. The arrow represents the direction of movement. Okay. Then we have 15 newton east. 15 newtons east. So this is the eastern part. This is the eastern part. Arrow, that's 15 newtons. So 15 newtons east. So if you look at your graph in mathematics, we have plus y here, minus y here, plus s here, and minus s here. So if the force is moving in the plus s direction, it will take plus. If it is moving in minus s direction, it will take minus. Okay, it will take minus. So now 15 newton is moving in the plus s direction, and 10 newton is moving in the minus s direction. So the resultant is the addition of the two, either given its signs, giving them their respective signs. So 15 newton will take plus, invisible plus is there, then plus, the plus at the middle is the word resultant. Then 10 newton is moving in the minus s direction, that will take minus. That's minus 10. Okay, so we have 15 minus 10, and that's what? 5 newtons. So 5 newton is resultant. Is it 5 newton west or 5 newton east? Because we have the west to be 10 newtons, we have the east to be 15 newton. So the east, which is 15 newton, the vector towards the eastern part, which is 15 newton, is bigger than 10 newton. So it will go in the resultant of the bigger number. So it's going to be 5 newtons east. 5 newtons east. So number 5 option. Number 5, the correct option is we have 1.5 newton west, we have 5.0 newton east, we have option C 15 newton west, option D 25 newton west, option E 150 newton east. So the correct option is 5 newtons east, option B. So let's go to number 6. We have an object weighs 0.25 newtons in air. An object weighs 0.25 newton in air and 0.21 newton when fully immersed in water. Calculate the relative density of the object. This question has to do with Archimedes' principle, which states that when a body is partially or fully immersed in a fluid, it will experience an upthrust, either or loss in weight, which is equal to the weight of the fluid displaced. So it is an upthrust. Okay. Now, if I weigh 500 Newton normally. If I weigh 500 Newton, if I find myself, if I go into the swimming pool, and my weight is measured inside swimming pool, I will weigh less. So if the body weighs, let's say 3 newtons in air, by the time it gets to water or kerosene or any other liquid, it will weigh less. So that difference in weight is the loss in weight, known as the upthrust or buoyancy. Okay, so an object weighs 0.25 newton in air. Let's look at how to solve this. So weight in air, let me use W subscript A. Weight in air, W subscript A is 0.25 newtons. Are you there? Now, then, and 0.21 newton when fully immersed in water. So weight in water is 0.21 newtons. Okay, calculate the relative density of the object. There are many formulas for relative density depending on the question. But the one that is suitable here is relative density equals to weight in air. All over weight of equal volume of water. Let me write it in words. Weight in air over weight of equal volume of water. So weight in air is given as 0.25 newton, but weight of equal volume of water is not weight in water. Are you there? So that equal volume of water is one that changes it. Okay, that phrase equal volume of water is what that changes the stuff. So weight of equal volume of water will now be weight in air minus weight in water. So weight of equal volume of water will be weight in air minus weight in water. So let's substitute. We have weight in air at 0.25, that's numerator, over weight of equal volume of water, that is 0.25 minus 0.21. That is weight of equal volume of water. And by the time you use your calculator, you will get 6.25. So relative density has no units. 6.25. So for number 6, the correct option is option E. Correct option is option E. An object weighs 0.25 newton in air and 0.21 newton when fully immersed in water. Calculate the relative density of the object. So option E is the correct answer, 6.25. Let's go to number 7. Okay, let me clean this. So for number 7 now, we're having two forces. Two forces of magnitude 25 newtons and 16 newtons are inclined at an angle of 120 degrees to each other. Calculate the magnitude of their resultants. Two forces of magnitude 25 newtons and 16 newtons are inclined at an angle of 120 degrees to each other. Calculate the magnitude of their resultant. When you see a question like this, the question is talking about parallelogram law of vectors. So that is when two vectors are represented by the two adjacent sides of a parallelogram. The resultant is the diagonal of the parallelogram drawn from the common point. So you just try to sketch a parallelogram. This is a parallelogram. Sketching. Okay, that's the parallelogram. Are you there? So let's say one side is 16 newtons, this side is 16 newtons, and this side is 25 newtons. Anyone, you can put your 25 here, put your 16 here. So the angle between them is 120. That's 120 degrees. That's the angle between them, 120 degrees. So the resultant will be the diagonal of the parallelogram. Diagonal of the parallelogram. Look at the diagonal of the parallelogram. Look at it. This is the diagonal of the parallelogram. So that's the resultant. Please put your direction, the arrow. Okay, very, very important. Okay, because our forces are vector quantities. So this is the diagonal of the parallelogram. The diagonal of the parallelogram is the resultant. Is the resultant. That is, let it be capital letter R. That's the resultant. Okay, that's the resultant. Then you can bring this one down. So let's say you can bring this one down, bring it down, bring it down, bring it down, bring it down to form a right angle triangle. Extend this, extend this. Are you there? So this angle 120 corresponds this angle. Corresponding angles are equal 120 degrees. Corresponding angles are equal 120 degrees. So if this angle is 120, what is this angle? Sum of angles on a straight line. This angle is 60. That's 180 minus 120. 180 minus 120. Sum of angles on a straight line is 180. So when you subtract 120 from 180, you have 60. So this angle is 160. So bring out this particular triangle. This triangle, bring it out. Bring it out. Bring it out. Are you there? So if you bring it out, you have something like this. You have something like this. Okay? Okay. So you have this angle as 60 degrees. You have this side as 25 newtons. Are you there? This side will also be what? 16 newtons. The opposite sides of a parallelogram. This side and this side. Opposite. They are the same. 16 newtons, 16 newtons. Okay? And we're looking for R, which are our resultants. Okay? So you apply cosine rule. You apply cosine rule here. C square equals to A square plus B square minus 2AB cos C, or A square equals to B square plus C square minus 2BC cos A, or the other way around, or A square equals to B square plus C square minus 2BC cos A. So like that, like that. So that cosine rule, it just means that the R you are looking for, that is R square equals to, there are two sides, 25 square plus 16 square minus 2 times 25 times 16. Then cos of the angle 60 degrees. So when you solve this, you have 625 plus 16 square, that's 256 minus 50 times 16. I'm going to do that. 50 times 16, 50 times 16 is giving us 800. That's giving us 800. 800. Then cos 60 is half, times half is 0.5. Are you there? So we have R square equals to 625 plus 256. 625 plus 256, that's giving us 881. So 881 minus 800 times 0.5, that's 400. Okay, so we have R square. We have R square equals to 881 minus 400. 881 minus 400, and that's giving us 481. 481. So square root of 481. Square root of 481 is what? Square root of 481, that's 21.93. So R is 21.93 newtons. R is 21.93 newtons. Okay, that is our resultant. That's our resultant for question number 7. Option A is 35.79 newton. Option B is 29.68 newton. Option C is 26.10 newton. Option D is 21.93 newton. Option E is 9.00 newton. So the correct option for number 7 is 21.93 newtons. So let's go to number 8. Let's go to number 8. Number 8 has to do with diagram. I have the sketch diagram on the board. Number 8, I have to sketch it on the board. Okay, this is it. Okay, we are given a rod or a meter rule. We're having a force here as what? 10 newtons, and we have having this. So we're having a pivot here or knife edge. Distance from here to here, they said, is what? 2 meters. 2 meters. So that's the question. They said calculate the moment of the force shown in diagram below. Moment of a force It's just like a turning effect. Are you there? So it's product of force and perpendicular distance. Perpendicular distance. The perpendicular must be there. It's not ordinary force times distance. Ordinary force times distance is work. That's the formula for work. But moment is force times perpendicular distance. So perpendicular distance is forming right angle or angle 90 degrees with the force. Okay, so now look at this force now. This force is 10 Newton. This force 10 Newton is not perpendicular, is not vertical. It's not up or down. Neither is it left or right. It's not purely up and down. Neither is it left or right. It is bending. It is bending at an angle. Sorry, we are given an angle 60 degrees. Here is 60 degrees. So is bending either at an angle of 60 degrees to the what? To the vertical. So when a vector quantity such as just like a force like this, when it is bending, sliding, when it's not purely vertical or purely left and right, purely horizontal, you are going to resolve, that's the word in physics. You resolve it into vertical component and horizontal component. That is, one part of it is going to have two faces. One part of it will be vertical component, one part of it will be what? Horizontal component. This is the vertical component of it. It will be F subscript Y. That's vertical component. While this is the horizontal part of it, that's F subscript S. Okay? F. So one will be cos, one will be what? Sine. Okay. So now the Fy will be cos, while the Fs will be what? Sine. That is, your Fs will be 10 sine 60 degrees, while your Fy will be 10 cos 60 degrees. So these are the two components of the 10 Newton force. These are the two components of the 10 Newton force. So this is the horizontal component Fs and this is vertical component Fy. So, but if the angle is here, if it is with the horizontal, if the angle is here, if it's not here, if the angle is here, Fs will be cos of that angle, while Fy will be sine of that angle. Take note. If the now the angle is 60 degrees and it's with the vertical like this, either the Fs is sine, the Fy is cos. But if the angle is here, if the angle is with the horizontal, either Fs will be cos, while Fy will be what? Sine. So what's our formula? Moment equals to force times perpendicular distance. Force times perpendicular distance. Okay, out of the two forces, Fs and Fy, which one is forming angle 90 with the distance 2 meters? Which one is forming angle 90 with the distance 2 meters? When you look at Fx is not forming angle 90 with distance 2 meters, but Fy is forming angle 90. Fy is forming angle 90 with distance 2 meters. So we are going to use Fy. So our force is now 10 cos 60 degrees. 10 cos 60 degrees multiplied by the distance 2 meters. That's 2. So at the end of the day, we have 10 times cos 60 is 0.5, then times 2. So at the end of the day, we have it as 10 newtons meter. When you multiply with the calculator, 10 Newton meter. Okay, Newton meter is the unit of what? Moment of a force. So the correct option there, we have option A, 5.0 Newton meter, option B, 10.0 Newton meter, option C, 17.3 Newton meter, option D, 20.0 Newton meter, option E, 34.0 Newton meter. So option B is the correct answer for number 8, 10.0 Newton meters or 10 Newton meter. That's for number 8. So let's go to number 9. Number 9, let me clean the book up because it's calculation. Take note of what I told you here. So let me clean the board for calculation. Okay. Number 9 is calculation. It said a football is projected to reach maximum range This question is talking about projectile. Are you there? A football is projected to reach maximum range if the initial velocity is half u. Express the highest if the initial velocity, they are given initial velocity, they say initial velocity is given as half capital letter U. How they give us in half capital letter U, that's initial velocity. Express the highest vertical distance attained in terms of U and G. Take sine 45 degrees as 1 over root 2. We are given sine 45 degrees as 1 over root 2. Okay, that is that. It said express the highest vertical distance attained in terms of U and G. Highest vertical distance attained. The highest vertical distance attained is the maximum height. You know, we have these formulas in projectile: time of flight, which is 2u sine theta over g. We have the range, which is u squared sine 2 theta over g. We have the maximum height, which is u squared sine squared theta over 2g. So the highest vertical distance attained is same thing as the maximum height. So which formula is capital letter H equals to u squared sine squared theta over 2g. Don't forget, sine squared theta means sine theta, or everything is squared. Okay, so let's substitute. So H equals to, what's our u squared? Our u is the initial velocity and it's given as half capital letter U. So half capital letter U, so square, because it is square, then sine theta, our angle there, sine theta, what's our angle? Our angle is 45 degrees. Why? Look at the question again. A football is projected to reach maximum range. Maximum range occurs when the angle is 45 degrees. Yes, in projectile. Maximum range occurs when the angle of projection is what? 45 degrees. So, and the question says a football is projected to reach maximum range. So our angle theta is 45 degrees. So sine 45 degrees all squared, because it's sine squared theta. So all over 2g. So let's break it down. Half u squared, that is u squared over 4 multiplied by half u, that's half u times half u, or let's say u over 2 times u over 2, that's u squared over 4. Then sine 45 has been given as 1 over root 2 all square. So divided by 2g. Let me use the smaller sign for division. Divided by 2g. Okay, so equals to, we have u squared over 4 multiplied by 1 over root 2 times 1 over root 2 will give you 1 over root 4, right? 1 over root 2 times 1 over, that's 1 times 1, 1. Root 2 times root 2, root 4. Okay, and root 4, square root of 4 is 2. Square root of 4 is 2. So square root of 4 is 2. That's 1 over 2. Then divided by this division, we change division to times. That's times. When you change division to times, the 2g becomes 1 over 2g. 1 over 2g. 1 over 2g. So let's multiply everything. U squared times 1 times 1. That's u squared. All over 4 times 2 times 2. 4 times 2, 8. 8 times 2. 4 times 2, 8. 8 times 2, 16. That's 16g. So our correct answer is u squared over 16g. Number 9. That's number 9. A football is projected to reach maximum range if the initial velocity is half u. Express the highest vertical distance attained in terms of u and g. So option A is u squared over 16g. Option B is u squared over 8g. Option C is u squared over g. Option E is 2u over g. So the correct option is option A, u squared over 16g, which is what we got here. So number 9 is option B, correct answer. Option A, correct answer. Number 9, option A, u squared over 16g. Alright, let's go to number 10. Number 10, take note of this. Number 10 now, let me clean the board. Number 10. For number 10. Number 10, we have a particle vibrate with simple harmonic motion. A particle vibrate with simple harmonic motion if its acceleration in meter per second square is 25 times its displacement in meters. A particle vibrates with simple harmonic motion if its acceleration in meter per second square is 25 times its displacement in meters. Find the period of the motion in terms of pi. Find the period of the motion in terms of pi. So the first thing you have to remember is that what is the formula for acceleration in simple harmonic motion? The formula for acceleration in simple harmonic motion is A equals to minus omega square x. Omega square is the angular velocity. X is the displacement. The x is displacement. The omega is the angular velocity, whose SI unit is radians per second. Similar letter A is the acceleration. What's the significance of negative sign? The significance of the negative sign is that the acceleration is directed towards a fixed point. The acceleration is always directed towards a fixed point. So you can, in this option, you can omit the minus sign. Okay, in this question you can omit the minus sign because in the options minus is not there either. You can omit the minus sign. Okay, now said a particle vibrates with simple harmonic motion, full stop, if its acceleration is 25 times its displacement. That is, acceleration A is 25 times x. X is the displacement. Are you there? So let's substitute. Substitute A as 25x in the formula. So we have 25x equals to omega square x. Okay, so s cancel s on both sides. So we are left with 25 equals to omega square. Omega is the angular velocity. The omega has a particular formula. We are looking for what? Find the period of the motion. We are looking for capital letter T equals to question mark. We are looking for period. Period is represented by capital letter T equals to question mark. We are looking for period. So we are having omega here. So omega is not the final answer. So we have to continue. So we have that. We know that omega equals to 2 pi f. Omega equals to 2 pi f. Okay, let's substitute. That was 25 equals to 2 pi f. 2 pi f all is squared. You know omega is square here. So we have 25 equals to 2 pi f squared. That is 2 pi f times another 2 pi f. That will give us 4 pi square f square. 4 pi square f square. Okay, we are looking for t. There is a relationship between f and t. F is the frequency. So f equals to 1 over t. Okay, f is equal to 1 over t. So we have to replace f with t. So we have 25 equals to 4 pi square over t square. Okay, it's because f is 1 over t. So making t square the subject, we have t square equals to 4 pi square over what? 25. They said we should leave an answer in terms of pi. Okay, now t square equals to 4 pi square over 25. So square root t square, that's t equals to square root of 4 pi square over 25. Okay, so t equals to the square root of 4 is 2. Square root of pi square, the square root will cancel the square. So the square root of pi square is pi over square root of 25, 5. So t equals to 2 over 5 is 0.4. So it's 0.4 pi seconds. That is the final answer. It's 0.4 pi seconds. That is the period of the body of the particle that vibrates with simple harmonic motion. Let's look at the option. Option A is 0.08 pi seconds. Option B is 0.12 pi seconds. Option C is 0.20 pi seconds. Option D is 0.40 pi seconds. Option E is 0.80 pi seconds. So the correct option is option D, is 0.40 pi seconds. That's number 10. All right, you can see on the board. Let me take water. Water is life. All is well. Okay, let's move forward. Let's go to number 11. Number 11. Okay, number 11. Let me clean the board. Number 11. Number 11. Okay, number 11. An engine was used to raise 120 kilograms of water through a height of 40 meters in 25 seconds. Calculate the power of the engine. I repeat, an engine was used to raise 120 kilograms of water through a height of 40 meters in 25 seconds. Calculate the power of the engine. We are given simulator G, which is the acceleration due to gravity, as 10 meters per second squared. So let's list out the parameters. An engine was used to raise 120 kilograms of water. That's mass. Mass letter M has been given as 120 kilograms. That's its SI unit, no conversion, of water through a height of 40 meters. Height H has been given as 40 meters. That's SI unit, no conversion. In 25 seconds. Time, simulator T, has been given as 25 seconds. Okay. Calculate the power of the engine. Power of engine, that's P equals to question mark. Don't forget that I'm given G as 10 meters per second square. Okay, the question. Alright. G is the acceleration due to gravity. So you begin to ask yourself, what is the formula for power? That is first thing that will come to your mind in the exam hall. Power. Formula for power, P equals to work over time. Work over what? Time. Power is equals to work over time. So if you begin to look at it, time is given, work is not given. But any other form of energy, any form of energy can replace W. The unit of work is joules. The unit of any other form of energy is what? Joules. So work can be replaced by any form of energy. It can be replaced by heat energy. Are you there? Which is ml or mc training theta. It can be replaced by electric energy, which is current square RT or high VT or V square R over T. It can be replaced by kinetic energy, which is half mv square. It can be replaced by potential energy, which is mgh. So which one are we going to replace W with here? We can see height. Are you there? Potential energy is a function of height. When you see height, you talk about potential energy. When you see velocity, you talk of what? Kinetic energy. So here we are having height. So we are going to replace that W, which is work, with what? Kinetic, with what? Potential energy. So now P equals to potential energy over time. Okay? So what is the formula for potential energy? mgh. So mgh over what? Time. mgh over time. So equals to P equals to, let's substitute. What is the value for mass? Mass is 120. Okay. G is 10. H is height. Height is 40. Is 40 over T. Time is 25. Is 25. So when you press everything together, what are we going to have? We have 120 times 10 times 40 equals to this, divided by 25. We have it as 1920. 1920. So P equals to 1920 watts. Watt is SI unit of power. It can also be joules per seconds. Are you there? or you say joules per seconds. So, but in the options, the unit is the watt is converted to kilowatt. The watt is converted to kilowatt. So 1920 watt to kilowatt, you just divide by 1000. So we have 1920 divided by 1000 kilowatts. So P equals to 1.92 kilowatts. So 1.92 kilowatts, that is a power. That's a power. So option A is 0.75 kilowatts. Option B is 0.83 kilowatt. Option C is 1.81 kilowatt. Option D is 1.92 kilowatt. Option E is 2.00 kilowatt. So correct answer is what? 1.92 kilowatt, which is option D for number 11. Option D for number 11. Let's go to number 12. Number 12. A machine with a velocity ratio of 7. A machine with a velocity ratio of 7. Let me clean the board. We have done that. Let's go to number 12. Alright. So a machine, number 12 now, a machine with a velocity ratio of 7 is 80% efficient. Determine the magnitude of the effort required to lift a load of 3,500 Newton. This one is under machine. Machine is a device that make work easier, okay, in which a small effort is used to overcome a large load. Let's list out the parameters. A machine with a velocity ratio of 7. Velocity ratio, that is V dot R dot, that's 7. That is our velocity ratio. VR is 7. Is 80% efficient. That's the efficiency is what? 80%. Efficiency is 80%. Determine the magnitude of the effort required to lift a load of 3,500 Newton. So the load is capital letter L equals to 3,500 Newtons. 3,500, that's the load. We're looking for effort. Effort, capital letter E equals to question mark. Effort, capital letter E equals to question mark. Okay. First and foremost, we are going to use two formulas to solve this question. We have different formulas. Are you there? Different machines with different velocity, formula for velocity ratio and all that. But generally, we have the formula as the efficiency equals to mechanical advantage, that is MA, all over velocity ratio, that's VR, times 100. Okay? Let's substitute now. Efficiency equals to mechanical advantage MA over VR times 100. What's our efficiency? 80. 80 equals to, what's our MA? We're looking for MA, though that's not the final answer, over VR. VR is 7 times what? 100. Cross multiply and make MA the subject. So MA, which is mechanical advantage, equals to 80 times 7, that is 560 over 100. Okay, so our MA, mechanical advantage, equals to 5.6. Mechanical advantage has no SI units. Are you there? You see in the next formula now. So our MA is 5.6. Now we're looking for effort, capital letter E. So there's a formula for mechanical advantage. So mechanical advantage equals to load over effort. Equal to load over what? Effort. Load over effort. Okay, our MA is 5.6. Substituting equals to load. Load is 3,500 all over effort, capital letter what? E. Okay, so cross multiply and make E the subject. So we have E, effort, equals to 3,500 over 5.6. 5.6. And when you press the calculator, you have 3,500 divided by 5.6, and that is 625 on dot. 625 on dot. So 625 newtons. Okay, look at the formula for mechanical advantage. Load over effort. The SI unit of load is newtons. The SI unit of effort is newton. So newton will cancel newton. That's why MA has no SI unit. So our final answer is now effort, 625 newtons. That's number 12. Option A 100 Newton, option B 475 newtons, option C 500 newtons, option D 560 newtons, option E 625 newtons. As you can see, the correct answer is option E 625 newtons. So let's go to number 13. Number 13 is not a calculation. The following are sources of energy. We are given 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 sources of energy. They gave us solar. Remember figure 1 as solar. Remember figure 2, they gave us petroleum. Remember figure 3, they gave us wind. Remember figure 4, they gave us nuclear. Okay, they now said which of these sources listed above are non-renewable. Non-renewable means non-replaceable. It means that they can be used up. Yes, they can be what? Used up. Are you there? So look at solar. Solar is from sun. So the energy from the sun cannot be used up. You can't finish it. Are you there? Petroleum can finish. Are you there? It can be exhausted. It can be used up. It can be exhausted. It can finish. Are you there? If petroleum is discovered in a particular area, by the time they start exploiting it, using it at a particular year, a particular time, it will finish. Are you there? So that is petroleum is non-renewable. Are you there? Then wind. The energy source. The energy from wind cannot be exhausted. Wind is everywhere. Are you there? You can't finish it. You can't use it up and say, okay, it has finished. No. So nuclear energy source. Nuclear is one of the materials. The main material used in making nuclear energy is uranium. Are you there? Is uranium, and uranium is a radioactive substance, so it can finish. It can be exhausted. Okay. So the ones final answer is now petroleum and nuclear. Non-renewable, which means non-replaceable. You can't replace them. They can finish. Okay, that's 2 and 4. Option 2 and 4. Look at the options. Option A 1 and 2 only. Option B 1 and 3 only. Option C 2 and 3 only. Option D 2 and 4 only. Option E 3 and 4 only. So our answer is 2 and 4 only, which is option D. 2 and 4 only, option D. Okay, that's number 13. Let's go to number 14. Number 14 has to do with a calculation question. Number 14. Alright, number 14. A rifle of mass 3 kilograms. A rifle of mass 3 kilograms fires a bullet of mass 1.96 times 10 to the minus 2 kilograms. If the bullet leaves the nozzle with a velocity of 155 meters per second, determine the magnitude of the recoil velocity. This question is talking about the linear of the principle of conservation of linear momentum. We say that the total momentum before collision is equal to the total momentum after collision in a system of two colliding bodies. So, and the formula will be m1 u1 plus m2 u2 equals to m1 plus m2 in bracket, close bracket, then v outside, capital letter V outside. That is the formula. Okay, m1 u1 plus m2 u2. Let me bring it down. Let me write it and bring it down. So the formula would be m1 u1 plus m2 u2 equals to m1 plus m2 in bracket, then v, capital V outside. Okay, so m1 is the mass of the rifle, m2 is the mass of the bullet, u1 is the initial velocity of the rifle, and the u2 is the initial velocity of the bullet, while v is the recoil velocity. It's when you find the recoil velocity. Okay, so let's look at the question and substitute our parameters. A rifle of mass 3 kg that is that's M1, mass of the rifle. That's 3 times U1. That's the U1 is initial velocity of the rifle. Initially, the rifle will not move. It's the bullet that will move. Are you there? It's the bullet that will be shot that will move. So the rifle will not move. Okay. So initially, the U1 is what? 0. The initial velocity of the rifle is 0. Then plus M2. M2 is the mass of the rifle. They said a rifle of mass 3 kilograms fires a bullet of mass 1.96 times 10⁻⁻2 kilograms. So 1.96 to non-standard form, that is 0.0196. Okay. So that is 1.96 times 10⁻⁻2. That is the mass of the bullet. Then times U2. U2 is the U substitute 2 is the initial velocity of the bullet. And God says if the bullet leaves the nozzle with a velocity of 155 meters per second, that means our U2 is 155 equals to, okay, M1 plus M2. M1 plus M2. M1 is 3 plus M2 is 0.0196, close bracket, V outside. So V is what I'm looking for. 3 times 0 is 0 plus is 0.0196 times 0.0196 times 155, and that's 3.038. 3.038 equals to this plus this, that's 3.0196 V. Okay, so that's 3.038 equals to 3.0196 V. So making V the subject, so V equals to 3.038 over 3.0196, and that gives us 3.038 divided by 3.0196, and that is 1.01 meters per second approx. 1.01 meter per second approximately. Okay, so let's look at the option. We have option A is 0.05 meter per second, option B is 0.65 meter per second, option C 1.01 meter per second. That's our answer. Option D 2.37 meter per second, option E 3.02 meter per second. So the correct option is option C, 1.01 meter per second. Let's go to number 15. Number 15. Okay, number 15. All right, number 15. Okay, you can back forward it so that you can see the solution again repeatedly. You can play the video again over and over, okay, for better understanding. Number 15, a ray of length, a ray, R-A-I-L, a ray of length 15.05 meters increases to 15.10 meters when heated from 20 degrees Celsius to 41 degrees Celsius. Calculate its linear expansivity. Linear expansivity of a body or of a solid is the increase in length per unit length per degree rise in temperature. So the question is under linear expansivity. Okay, now let's list out the parameters. A ray of length 15.05 meters, that is the initial length, L1. L1 equals to 15.05 meters. Increases to 15.10 meter, that's final length, which is L2, S2, 15.10 meters, 15.10 meters, 15.10. When heated from 20 degrees Celsius, 20 degrees Celsius is the initial temperature. Let's say theta 1 is 20 degrees C. Okay, when heated from 20 degrees C to 41 degrees C, that's final temperature. Theta 2, that's 41 degrees C. Okay, calculate is linear expansivity. Linear expansivity is represented by alpha. Alpha equals to question mark. So what's the correct formula? Suitable formula. Then everything is in SI units. Are you there? So we have alpha equals to L2 minus L1 over L1 bracket theta 2 minus theta 1. That's the formula. So let's substitute. So alpha equals to, what's our L2? Our L2 is 15.10 minus L1. L1 is 15.05 all over. What's our L1 again? All over. L1 again 15.05. Open the bracket. What's our theta 2? Theta 2 is 41 minus theta 1 20. So everything gives us 0.05 over 15.05 times 41 minus 20, that's 21. So alpha equals 0.05 over 15.05 times 21. Okay, here's my calculator. That's 15.05 times 21, and that is 316.05. 316.05. So divide it, we have 0.05 divided by 316.05 equals to that is 1.58 times 10 raised to the power of minus 4 per Kelvin, or you say per degree Celsius. So that's the correct answer, per Kelvin or per degree Celsius. You don't need to convert the temperature from Celsius to Kelvin, no, because this is it. When it's talking about gases that you convert from Celsius to Kelvin under Mohs, okay? But here it's it, so you don't convert Celsius to Kelvin. So let's look at the options. The question, okay. Option A, 1.50 times 10 raised to the power minus 4. Option B, 1.58 times 10 raised to the minus 4 per Kelvin. Option C, 1.80 times 10 raised to the minus 4 per Kelvin. Option D, 3.20 times 10 raised to the minus 4 per Kelvin. Option E, 7.19 times 10 raised to the minus 4 per Kelvin. So the correct option is option B, 1.58 times 10 raised to the minus 4 per Kelvin for number 15. So let's go to number 16. Number 16 now. Number 16 is not a calculation. Which of the following thermometric properties is employed in a liquid in glass thermometer when in use? A liquid in glass thermometer, a good example is the clinical thermometer. The clinical thermometer that is used in hospital to check your temperature, are you there? It uses mercury, so in form of a liquid. So mercury is a liquid there. So clinical thermometer is a good example of liquid in glass thermometer. So the volume changes with temperature. When the temperature of the body is high, and the thermometer is put under your armpit, or so it will the volume of the mercury in that clinical thermometer will expand, as in it will move forward along the scale. But when the temperature of the body is cool, when the temperature is cold, either the volume, it will contract. The volume of the liquid of the mercury will move backward, either. So the correct option, let me read the question again. Which of the following thermometric properties is employed in a liquid in glass thermometer when in use? So change in option A, change in color of the liquid. That is wrong. Option B, change in pressure of the liquid. No, pressure of the liquid is gas thermometer. Are you there? Option C, change in resistance of the glass. Resistance of the glass, it doesn't have to do with the resistance of the glass. The glass does not even have any resistance like that as such. Option D, change in volume of the glass. No, not the volume of the glass, but the volume of the liquid. So option E, change in volume of the liquid. Option E is the correct answer. Change in volume of the liquid, not change in volume of the gas. Number 17. Look at 17. Now 17 is calculation. 17 is calculation. Okay. Calculation. That's number 17. I read the question. The amount of heat generated in a 2 ohm resistor. The amount of heat generated in a 2 ohm resistor by a current of 5 amperes passed for 40 seconds is used to evaporate 2 grams of liquid at its boiling point. Determine the specific latent heat of the liquid. I repeat. The amount of heat generated in a 2 ohm resistor by a current of 5 amperes passed for 40 seconds is used to evaporate 2 grams of liquid at its boiling point. Determine the specific latent heat of the liquid. Let us list out our parameters. So the amount of heat generated in a 2 ohm resistor, that resistance has been given R, that's 2 ohms, okay, by a current of 5 amperes. Capital letter I is 5 amperes. Resistance R, capital letter R, 2 ohms. Current, capital letter I, 5 amperes. Pass for 40 seconds. So times letter T times 40 seconds, okay, is used to evaporate 2 grams of liquid. That's mass, 2 grams. Mass M, so letter M is 2 grams. Okay, determine 2 grams of liquid at its boiling point. 2 grams of liquid at its boiling point. Determine the specific latent heat of the liquid. Specific latent heat is represented by small letter L. Small letter L equals to question mark. So here, the resistor, the current, the time, there make up electric energy. And then it's used to evaporate 2 grams of liquid at its boiling point. That gives us heat energy. So electric energy is converted into what? Heat energy. Is that heat that is used to evaporate the liquid. Okay, so we are going to look at the formula for electric energy. Electric energy can be current square RT, can be PT, can be V square R over T, can be IVT. Those are the formulas for electric energy. But it now depends on the parameters we are given. Are you there? So which one is suitable? When you look at this particular parameters now, you find out that it is current square RT that is suitable as the electric energy. Equals to the heat energy. The heat energy can be MC change in theta and it can be ML. Heat energy, it can be MC change in theta, it can be ML. So MC change in theta is the C there is a specific heat capacity in case you have to find the specific heat capacity, and it can also be ML. L is the latent heat, and that's what we're asked to find. So you have to use ML. Okay, so let's substitute our parameters. Current square, that's 5 square, multiplied by resistance 2, multiplied by time 40, equals to mass 2 times what? L. As you can see, I didn't convert the mass in grams to kilograms because I look at the options. The options is in joules per grams. Joules per grams. The options are in joules per gram. So I don't need to convert the mass to grams again. Either I think the options are in joules per kilogram. Then I'll convert from grams to kilogram by dividing by 1000. Is that taken? All right. Okay. So that is 25 times 2 times 40, that's 80, equals to 2L. So 25 times 80, and that has given us 2000. That is 25 times 80, that's 2000. Okay, 2000 equals to 2L. So L is 2000 over 2. So L is 1000 joules per what? Gram. Don't forget that I didn't convert the mass to kilogram. So joules per gram. That is our latent heat. Look at the options. 200, option A, 200 joules per gram. Option B, 500 joules per gram. Option C, 998 joules per gram. Option D, 1000 joules per gram. Option E, 4000 joules per gram. So option D is correct answer. 1000. Option D is correct answer. 1000 joules per gram for number 17. Let's go to number 18. Number 18 is not a calculation question. Number 18. Condensation of water vapor is directly responsible for the following phenomena except, I repeat, condensation of water vapor is directly responsible for the following phenomena except option A, cloud, option B, dew, option C, fog, fog, option D, mist, option E, rain. What is condensation? The process by which a substance changes from gaseous state to what? Liquid state. So water vapor is in a gaseous state. Either it will change to a liquid state when it is cool, when the temperature drops, either when temperature is reduced. And you can see water vapor is in the atmosphere as a result of evaporation from the surface of sea or ocean. We have water vapor in the atmosphere. Okay, so when it is cool, when the weather is cool, either the water vapor in the atmosphere will condense, that will change into liquid state, to form different tiny droplets of water. And these different tiny droplets of water are the dew, the mist, the rain, either. So are the dew, the mist, the rain. When it's so heavy, it's rain, either. So the fog, when the mist is severe, when its mist is severe, we have fog. And that is when, if in the day, when fog is occurring in the day, the motorists, they put on their headlamps so that they will be they will be able to see very well, because fog reduces visibility, either in the daytime. So that is mist. But when it's so much, when it's severe, it's fog. So we know dew is as a sort of condensation of water vapor. But cloud is suspension of water vapor in the atmosphere. Either cloud is suspension of water vapor in the atmosphere. So option A is except one. We say condensation of water vapor is directly responsible for the following phenomena except. So we have cloud as the exception. That option number 18, option A, correct. Option A is the correct option, cloud. Number 19 is a calculation question. Number 19, okay, number 19, a fixed mass of a gas occupies a volume of 450 cm cube at a temperature of 27 degrees Celsius and a pressure of 65 cm mercury. Calculate the volume if the temperature increases to 127 degrees Celsius at constant pressure. I repeat, a fixed mass of a gas occupies a volume of 450 cm cube, 450, at a temperature of 27 degrees Celsius and a pressure of 65 cm mercury. Calculate the volume if the temperature increases to 127 degrees Celsius at constant pressure. Constant pressure. This is Charles' law. Charles' law states that the volume of a given mass of a gas is directly proportional to its absolute temperature, or temperature in Kelvin, at constant pressure. When you state the law, you must put absolute temperature, or you put temperature in Kelvin. If you don't put it, the law is wrong. Either that means you have to convert our temperature in degrees Celsius to Kelvin. You have to convert your temperature in degrees Celsius to what? Kelvin. Okay, so at constant pressure we are going to use Charles' law, and Charles' law is V1 over T1. That's V1 over T1 equals to V2 over what? T2. That's Charles' law. Okay, you can also use the gas equation, P1 V1 over T1 equals to P2 V2 over T2. But the P1 and P2, they are the same thing. So they will cancel out. And when they cancel out, you end up getting V1 over T1 equals to V2 over T2 back. Okay? So the choice is yours. So that's the tool. Let's convert. Okay, it said a fixed mass of a gas occupies a volume of 450 cm cube. That means V1 is 450 over T1 at a temperature of 27 degrees Celsius. So that temperature 27, we convert it to what? Kelvin, by adding our T1 is 27 degrees Celsius. You convert it to Kelvin, that is 27 plus 273, and that gives us 300 Kelvin. 300 Kelvin. That is T1. And our T2 is 127 degrees Celsius. T2 is 127 degrees Celsius. You must multiply to Kelvin by adding 273. So 127 plus 273, and that gives us 400 Kelvin. 400 Kelvin. So we now come back and substitute. V1 is 450 over T1. T1 is 300 equals to V2. V2 is what we are looking for over T2. T2 is 400. So when you cross multiply, you have V2 equals to multiply and make V2 the subject. We have 450 times 400 over 300. And V2 equals to, at the end of the day, we have our answer as, let's press that, that's 450 multiplied by 400 equals to this, divided by 300. That's 600 on dot. 600 on the 600 centimeter cube, because V1 is in cm cube, so V2 will also be in cm cube. 600 centimeter cube is the final answer. Okay, so option A 37.5 cm cube, option B 127.2 cm cube, option C 188.0 cm cube, option D 450.0 cm cube, option E 600.0 cm cube. As you can see, for number 19, our correct option is what? Option E, 600.0 cm cube is same as 600. Okay, number 20 now. Number 20 is not a calculation question. Number 20, which of the following devices is used for storing electrostatic charges only? Electrostatic charges only. Which of the following devices is used for storing electrostatic charges only? Option A, capacitor. Option B, electrophorus. Option C, electroscope. Option D, lightning conductor. Option E, proof plane. When you look at this option, let's analyze. Option A, capacitor. Capacitor is used to store charges, either, but not electrostatic charges. Charges at rest are called electrostatic charges, either, but the charges that move along electric wires, with the wiring of your house, the rate at which those charges are moving is called current. Are you there? And as charges are moving from one place to another along the wire, we can call it dynamic charges. They are moving from one place to another, and that is kind of charge that capacitor stores. That's kind of charge capacitor stores. But when it comes to the occurrence of lightning or thunderstorm in the atmosphere, you find that in the atmosphere we have parts, charges, we have positive charges, molecules or ions that are positively charged, and molecules or ions that are negatively charged in the atmosphere. So when these positive charges and negative charges meet, when they attract, a spark is formed. A spark is formed, either accompanied with light, accompanied with sound, either. So that spark will produce heat. Okay, and that heat can make a building to collapse, and that's why in some buildings lightning conductor is what installed at the upper part, at the roof, so that it runs from the roof down to the earth, so that the heat from the lightning, from the thunderstorm, will be absorbed by that particular conductor down to the earth. And they normally use copper conductor. Copper conducts. They normally use copper as the lightning conductor. So the kind of charges that you can find in the part of the atmosphere like that is electrostatic charges, because they are not moving either. Okay, and then also when you take a pen, and you rub it against your air vigorously many times, either, and you bring that pen close to a piece of paper, it will relatively attract the paper, either. So that means both of them have different charges, either. So that is what we call electrostatic charges. Okay, and it's stored by electrophorus. Electrophorus stores charges. Electroscope is to detect the nature of charge on a body to dictate. I will explain lightning conductor. Then proof plane. Proof plane is used to transfer electrostatic charges, for transferring electrostatic charges. But the correct option now is what? Electrophorus. It stores electrostatic charges. Okay, that's option B, electrophorus. All right, that is number 20. So I'm going to, like, at this point now, look at this on the board. At number 20, I've done number 20. The correct option is electrophorus. So if you need home lesson teacher, if you need an home lesson teacher, private tutor, okay, I'm there for you. I'm into that. So private tutor for preparation for common entrance, for common entrance, for junior WAEC, and junior NECO exams. Then WAEC, senior WAEC / NECO, senior NECO exams. Also WAEC GCE / NECO GCE. Okay, if you need home lesson teacher for that. And then JAM exams, also IJMB is for you to enter year 2. IJMB is for you to enter year 2. Okay, IJMB. Okay, SAT maths, also preparation for SAT maths, and also other lower classes for maths. Are you there? For chemistry, for physics, for physics A-level or O-level, physics, biology, maths, chemistry, physics, biology, technical drawing, that's TD, technical drawing. So if you need home lesson teacher for that, I'm available. Any part, are you there? Any part in this country, I'm available. So I'm going to come there live and tutorialize your kids or you yourself. Also, whether you are in year 1, year 2, year 3 in university and you are struggling with physics, with chemistry, with maths, with further maths, please feel free to contact me. You call me or you WhatsApp me on 09074526311. That's my WhatsApp number. That's also my phone number. 09074526311. 09074526311. You need home lesson teacher, briefly, and with any form of this. You can just test me first. You see the beauty of all this, beauty of maths, chemistry, physics, biology, technical drawing, and further mathematics. Don't forget the phone number or WhatsApp number is 09074526311. If you're outside the country, if you're outside Nigeria, the code is +234 to call, +234 to call outside Nigeria. And then please don't forget to click on the subscribe button and the like button. When you click on subscribe button, you're able to see other videos that I've uploaded. Are you there? That I've uploaded. And then you need to okay, we stop at number 20. So I will upload another video that will continue from 21 to, because we are going to 60 questions. in the objective. When we are done with that, we'll now go to the theory aspect. We're going to analyze everything bit by bit. So we stop at number 20 in this particular part. The next video is from 21. We finish it up from 21. Okay, so search for the next video, which is the part 2 of the objective question for NECO. And don't forget that all this will help you also to pass your WAEC and other exams. Okay, all right, thank you so much. Bye for now. If you have any questions, anything, just call me on that 090-745-26311. This is Campus Academy, where everything is made simple, where science is life. Campus Academy. Are you there? Campus Academy is my YouTube name. So, and then my email is campusacademyyt@gmail.com. Campus Academy YT, small letter Y and small letter T at gmail.com. Okay, so feel free. Okay, all right, thank you so much. Bye for now.